Hello, everyone. Welcome to Alexa and Friends, the special opportunity we have once in a while to interview a bunch of people that are meaningful to the world of Alexa. My name is Jeff Blankenberg. You probably know that by now, but I am very fortunate to have with me today Gokhan Tur, who is a senior principal scientist on the Alexa AI team. So, Gokhan, thank you for being here.
Thank you. Thanks for having me.
Certainly. So, there's a couple of things that I like to do at the top of every one of these interviews, which is give people a little glimpse into kind of who you are. And I've mentioned to you that I like to ask these silly questions, but I really think they do a good job of illustrating for people kind of a little bit about how you think or what your beliefs are. So the first one that I like to ask is if you could choose any superpower. So imagine all the comic books you may have read as a child or anything like that, or movies you've seen. You only get to pick one power, right? So Superman is a combination of a bunch of powers. But if you just get to pick one, what superpower would you pick? And then, of course, why?
Yeah, I have seen you asking this question to others, and I have been thinking and waiting for this question to come. It's actually a tough question. It's a tough question. And at some point, I actually thought of a real good one, and then I forgot to write it down, and I cannot still remember that. But one thing for sure is that I think I am more on the logical mathematical side. Sometimes I just wish to get a number. I know that that number exists. Like a stupid example is like how many trees I can see at this moment, and there is a correct answer to that. So it is correct. It is non-arguable. It is nothing like I will do anything with it. But sometimes I want to know that number, and I for some of the things, of course, you can do a web search. Try to get an approximate thing like how many COVID cases, but there is actually a number, number of people in my country who is actually positive, or it can be anything related to history, like who actually killed this guy, who pulled the trigger, some facts. And I am interested in history, and the second interest is space. What is out there, because it is a fact. When you go beyond the galaxies, how many galaxies, there is a number, and there is a fact, and I don't think nobody will ever have that kind of superpower, but I really wish I had.
Wow, that's really interesting. So I don't know how to quantify that exactly, but that's a really interesting superpower. It's basically kind of like all-knowing, but it could also be somebody that could travel to any place in time and space, because then you could verify those things rather than just knowing them.
Yeah. So it is not subjective, there is a fact.
Yeah.
Mm-hmm.
We're gonna call you Fact Man. I like that. This is that's a good superpower. I think that would be incredibly valuable. I like that a lot. All right, let's do two more. There's one more that I like to ask. Do you play any kind of music? Do you play any instruments?
Oh, no, I am super bad in those things.
That's okay. But do you enjoy listening to music? Do you have favorite artists or bands?
Okay. Mostly classical, like Baroque era.
Okay. I do love some good classical music. I can agree with that for sure. Well, one of the questions that I like to ask people is I want you to imagine for a moment that you're in a rock and roll band, and you guys have just released your first album. What is the title of that album? Oftentimes, it's very reflective on who you are or where you are at the time. I'm curious to know what you would name your first album.
I see. I think it will be, something abstract, which will have like some ambiguity, something like, here we rock kind of thing, ambiguity. Probably not like a phrase, but just, one or two words.
Okay.
Maybe we can say something memorable, people will remember
Yeah.
that album name.
Something like true facts. That would be a good one.
Maybe. So something like memory rack kind of a thing.
Nice.
So people will implicitly think that they need to remember that.
I gotcha. All right, I like that. That's a tougher one for people. I know that's a tough thing to come up with sometimes. Is like, what are the words that best reflect what I'm thinking about or how this stuff works? All right, now on to my last question, my favorite question. I want you to imagine for a moment that you are trapped in a long alley in a city, and at one end of that alley is a huge horse-sized duck. So I want you to imagine a duck the size of a horse. And at the other end of the alley, there are 100 small duck-sized horses. You have to get out of this alley because otherwise you're going to get eaten alive. Which one would you prefer to fight your way out through? One giant duck or a bunch of tiny horses?
So how many horses you said?
100 tiny horses.
Yeah.
About the size of a duck each, so not very big.
Yeah. So a couple months ago, you also interviewed my spouse, Gokhan Tur, and then after the show, actually, we discussed that. And for me, 100 is too much, man. So my threshold is like something like 14.
14.
If there were 14 ducks, I would go. But then I will go with a horse-sized duck.
One horse-sized duck. I think I agree with you.
Yeah.
I've mentioned to several of our guests that I think there's something to be said for trying to tame that horse-sized duck. Being able to ride it would be amazing because then you could be on a duck and it could fly. There'd be a lot of opportunity there if you just made friends with this giant duck. So, I think I agree with you. I think that would be my perspective as well.
Yeah, my reasoning is the other way around. The other side is too crowded.
Too crowded. I mean, that is a lot. If you imagine being surrounded by just 100 normal ducks, that's pretty intimidating. So I agree with you. All right, so you mentioned your wife, Dilek, who I had a wonderful conversation with a while ago, and she's also a senior principal scientist, right?
Correct.
That's great.
Correct.
So we got to talk about her career and her involvement in the Alexa Prize. There was a lot of cool things that we did there, and I'd like to know. Well, let's get a little history. How long have you guys been married? Let's start there.
More than 20 years.
20 years, my goodness. My wife and I just hit 21 this year, so congratulations. That's
we were in grad school.
Oh, you met in grad school. That's great.
Yeah, we married in grad school.
Oh, I see. But you've known each other for quite a while.
Yeah, since 7th grade.
Oh my goodness, that's excellent. That's wonderful. All right, so one of the things that I like to do, in your own words, of course, is talk about your history. You're a senior principal scientist, you're on the Alexa AI team, but one of the things that I think is really interesting for folks, and you and your wife are exceptions to this rule, most of the people that I talk to didn't go to school thinking about how am I going to apply conversation, how am I going to build things that really focus on conversation and voice. But it turns out that the two of you actually have. You've spent a lot of time there. So can you give me a little background on what your history is? I know you originally came from Turkey, but I'd love to know more about where you went to school or what you think the meaningful moments were in your life that kind of the pivotal decisions you made to get to where you are today.
I think we had the opportunity to work with pioneers in machine learning based speech and language processing. This was very fortunate of us. When we started a PhD in Turkey, we had a wonderful professor who is deep into statistical language processing. And then we had the opportunity of spending 2 years during PhD in the US. 1 year we were an extended intern. They called us international fellows after a while at SRI International. We worked on a DARPA-funded program on understanding topics in a conversation.
Oh, cool.
Like what are these guys talking about? And this is, the first time we met Conversational AI. And we stayed 9 months at Hopkins, and then we had the opportunity of working with gurus in speech and language processing, and 3 months in Carnegie Mellon University working on machine translation. And after we graduated from Bilkent, we joined AT&T Labs, the good old Bell Labs.
AT&T and Bell Labs.
This is, another thing, another thing that we were fortunate because at that time AT&T was big in speech and language processing. They had this cool product they were deploying on call centers because you're AT&T, you empower most of the call centers of Fortune 500 companies. And then one bit of a thing they were doing is concierge. When you call some company like a pharmaceutical company and you say, I want to refill my medication, or you call a cable provider and you say, I have a problem with my cable. They were trying to route this call within that company so that it is best processed. And if you think about it, this is one bit of conversational AI. You get input speech, you try to interpret into one of the N categories, and then you route it. It was called How May I Help You? And it is usually deemed to be a pioneering conversational AI system.
Yeah, for sure.
Most people think that conversational AI started with Siri, but actually it didn't. So it existed before 2010.
But is it fair to say though that something like How May I Help You from AT&T it's certainly more primitive than what we have today, but it was certainly a great example of conversational AI. I agree with you.
Yeah, of course. But even that, primitive application, it was super impactful because for the, call centers, that business is still there. There are still companies, trying to automate call centers. That's a big cost saving for them. And then the other thing is it's an opportunity because you get all these, millions of utterances belonging to all these companies. And for a scientist, it's like a gold mine.
Yeah.
Right. So the minimum viable thing is, you classify each utterance into one of the N classes. So very quickly we started expanding on that. Like people say, I have a problem. Okay, what is your problem? It is, a primitive dialogue. But when you ask the follow-up question, people give specific responses. So the whole thing started to evolve. Of course, machine learning was just starting. Speech recognition was not as good. We were dealing with, about 30% word error rate. But, still, they made good applications.
No, that's excellent. So I guess that's all I want to talk about for now, I guess, on that topic. I was thinking about, I had one other question that I asked at the beginning, and I want to make sure I touch on this, because I always find this really interesting. Did you ever find that there was a point in your career where one option was to go the path that you did end up taking, but do you ever look back and say, wow, if I had made that decision, I would end up over here, I'd be doing this other thing completely different instead? Was there ever a time where you were torn to make a big decision in your career and you kind of had to go one way or the other?
Topic-wise, no, actually. So this is a super fruitful area, and this is one of the things where you can have a foot on the ground, head in the sky kind of research, which I enjoy a lot. Because indeed sky is the limit here. Turing has a famous saying, like I think 1947, by the end of the century, people will be able to speak to machines without thinking otherwise is not possible. We sometimes joke maybe he's talking about 21st century. And I don't know whether I will see this vision before I die. But this is a good actually target where we try to approximate every day.
Yeah.
And seeing advances every day is super exciting.
I completely agree. It's been remarkable just the 4 years that I've been on the Alexa team, just the advances that have been made in those 4 years. So to understand how we got here, I don't always have a lot of that history, and this is really helpful to hear.
Yeah.
All right. So one of the things that you mentioned in your history was that you were actually involved in some DARPA projects at SRI, correct?
Yeah, after AT&T, we stayed at AT&T 5 years. After that, I joined SRI International. And the reason is, SRI International is soft money, mainly relying on government-funded projects. And in 2005, they got two big fundings. One of them is about translating some spoken and written text and answering questions on them. It was called Gale.
Okay.
And then that was a huge boost for the speech and language processing community. So many, academic and industrial sites were funded by that, including, European partners. And then the second one was called Kalo. It was an AI project. So it was trying to build an AI agent to organize your personal data like email, calendar, and whatnot.
Nice.
Most people don't know that, but Kalo is spinned off as Siri by SRI International. So this is why the name is so similar. And the other thing is when Kalo project finished, Siri was actually deaf and mute. But then mobile phone came in 2007, and then in the spin-off they made a brilliant choice of enabling it like a personal assistant.
Yeah.
And this Kalo project was different than others. It was not competitive; it was cooperative. So SRI funded other partners through the Kalo project, and I was in charge of speech understanding there. When Kalo, for example, attends conversations or meetings with others.
Okay. So you worked on these projects. What the time frame for that was? What the early 2000s?
No, this is 2005 to 2010.
Okay. So what were the early days like working on stuff like that? I mean, I think we all take for granted sometimes the access and the data and the reliability that we have from things like Alexa and some of the other assistants that are out there. But what was it like then?
So I would say there are two big differences for both, AT&T and these DARPA projects. Number one is how we handle data. So privacy was not a big concern. The AI ethics, fairness kinds of things were not the priority. The priority is making them work because they were not working. This is pretty deep learning era, and everybody was trying to customize the existing machine learning algorithms, or come up with better features so that existing machine learning algorithms can actually work better. And at some point, feature engineering became the focus instead of data and the model. So this is one big thing. The second big thing is that aside from the data, so in each of these cases, since it is very, very targeted, people were building very narrow applications instead of like a generic deep learning model which can do n different tasks. So you have a some kind of machine learning algorithm. You adjust that algorithm according to your task, tailor it, and the field was also much smaller. Like at that time, NeurIPS was hundreds of people. We had, speech and language processing conferences, hundreds of people. I remember like ACL conference, which is like the main natural language processing conference, when machine learning papers were exceptional. And nowadays it's impossible to find any non-machine learning paper.
Wow. So it used to be that you'd rarely see anything, and now that's all there is.
Yeah. Actually, the first machine learning papers in NLP appeared like late 80s. early 90s, very, very late if you think
Yeah,
about
oh,
it.
for sure.
Mm.
All right, so one of the things that you were very modest in your description of your early career, but when we talk about AI and especially things related to conversation, you've worked on pretty much all of them, right? You talked about the AT&T's "How may I help you" system, but you've also had a hand in Siri and Cortana and Google Assistant and now Alexa. Um, what are some of the big? I mean, that's amazing. What are some of the big advancements in voice AI that you've had an opportunity to witness as part of your career? I mean, it's amazing to me.
Yeah, I don't think I know so many people who worked on all these, big four.
Right.
But this also gave me, additional benefit. Now, I can see the larger scope because I am not limited to, one solution. And even though you may think that, all of these conversational AI systems approach the problem similarly, they don't. So there are lots of nuances. So I had the opportunity to get, better insights on what is possible and then what should be next. This is actually another strength and opportunity I had. The second part of the question. What is changed? So I talk about data and the models, but then on the conversational AI side, the biggest thing is I mentioned at AT&T the focus was core routing, right? And then when Siri-like applications started, it was more like single shot, set a timer for 2 minutes. And then the problem is, finding the intent and the associated slot.
Right.
And then nowadays, what we are talking is natural conversational dialogue. And I think given all the advances in, speech processing, language processing, core machine learning, deep learning-based algorithms, so now we are one step closer to this vision. I still think that people will not be able to talk to machines on anything they want. It is still targeted understanding, but the conversational will be much, much richer. And this is our goal in Alexa AI as well.
I love it. We as developers, a lot of the people that are watching, and certainly myself, I am a developer of conversations, right? I'm building an application, but really what I'm building is a way to infer as best I can what you said and try to respond back with whatever I think is the best possible response to those things. But having something that's more natural, that doesn't require a developer to write every single line to every single response to every single thing, I think is
Yeah.
that's the future. That's what I'm really looking forward to seeing, where the voice itself can make decisions on its own without having to lean heavily on a whole bunch of code.
I hope, yeah, we will see those days. So everything happens, in phases. First, there are ideas, then prototypes. You will see, early demos, and then product, takes a while.
Yeah. All right. So let's talk about what's coming. Right. We have the annual Amazon Devices event last week. I don't know if you actually got a chance to watch it, but I sat there and just head explosion after head explosion of cool things between the Echo Show 10 that can rotate and move around, and even some of the nuanced things that they added to the Fire TV I thought were really interesting. But those are new devices, right? Can you tell me more about like the AI-driven announcements that were announced during that event?
Yeah. So VP of Alexa AI, Rohit Prasad, talked about three big things and actually demonstrated some of them. So I am currently with Alexa AI Natural Understanding team. And then this team's goal is, building more conversational, more natural interactions. So if you think about it, this team is in charge of, core of the core technology for Alexa. So whatever you say, this team is converting this into some semantic interpretation, so Alexa can take some action. And this can be, related to, this domain to that domain. So this team is providing the platform technologies for each of these experiences. And this devices event was extremely exciting, and actually it was very inspirational to watch. One of the big announcements in that event was Rohit Prasad demonstrating an interactive teaching capability. So he asked the Echo device, set this slide to Rohit's reading mode. And normally you will get, I am sorry, I don't understand you kind of a response. Right. And with this, interactive teaching capability, Alexa responded, I don't know Rohit's reading mode. Can you teach me? And if you think about it, this is super important because now Alexa is taking action and asking for users teaching her to improve. And this is extremely exciting because this is another example of foot on the ground, head in the sky kind of an approach. Where you can demonstrate this technology in this, narrow example. But after thinking 5 minutes on where this technology can go, it is like the holy grail of conversational AI. There are, a couple papers and maybe a couple PhD theses on this area. But this is one of the most challenging tasks in conversational AI. When the agent doesn't know, can the agent interact with the user to get the task done?
Yeah.
And then there is no developer, there is no code, you directly learn from the user. And this is, super exciting. So this project was existing when I joined Alexa AI in February. The announcement was for smart home, for lights and thermostats. So this is a good, first step to showcase that actually, we can make it work in a large-scale production system. And then once we work this, the additional features to this capability will come afterwards. And Rohit also mentioned a second one, that is the declarative concepts or implicit intents. For example, when you say, Alexa, it is too dark in here, if the action is not implicit or I cannot see anything, right? Maybe it is daytime and you may want to open your blinds if you have a, smart blind, or maybe you want to, turn on the lights, or maybe you have, multiple lights. And in these cases, instead of the developer, Alexa developers, enumerating each of the use cases and then, writing rules for each of the customers, the idea is, why don't we simply ask the user? Right? Your intent is, not explicit enough. What do you actually want us to do?
Yeah.
And if you know that, there are two options, blinds or lights. Just ask them, do you want to turn, open the blinds or turn on the lights? And this is another bit of learning from the user via interaction.
I love that. There are so many times where you'll talk to an assistant and you know what you want, but it can't seem to figure out or understand exactly where you're trying to route that request. I'm sorry, there isn't a group named living room. Oh, I called it family room. Of course, that's that kind of stuff happens all the time. So being able to infer and interpret and move around, I think that's brilliant. That's excellent. All right, so what can you tell us about the science behind these kinds of capabilities? Because I don't think it's very often for our audience to get anything more than like, hey, this thing works now. Go ahead and try it. But I'd love for you to share with us, like, what does the science behind doing something like that look like?
So what's happening is that when Alexa sees that it cannot fulfill the request, it is engaging in this sub-dialogue with the user. And then this sub-dialogue is the interactive learning session with the user. So that means you need to have, two parts. In the first part, you need to understand that actually this sub-dialogue will help people. So what the team has built is something called a concept parser for understanding the gaps in Alexa. For example, when you say turn on the, set the light to study mode, this parser says, I know everything except this piece, study mode. And then this is like a flag. Okay, now we believe that we can actually engage in an interaction with the user, and then handle this request. And of course, there are so many cases. This model will not fire because we cannot handle all the requests using this technology. So we need to go very carefully. Like if the user says set the light to never mind, it will be stupid to ask what do you mean by never mind, sure. Right? So after this fires, the sub dialogue kicks in, and then we ask the user, I don't know what study mode or reading mode means. Can you teach me? And then the understanding the user's answer is actually harder than understanding the first turn, because at that point the user can say anything, and it is uncharted territory at this point. Because it has never been done before. User can say, study mode means study mode, or user can say study mode means, 50% brightness. Or user can say study mode is the mode that is, comfortable for my, reading. So you need to interpret each one of them, or user can be non-cooperative, like stop, cancel kind of things. And then you need to interpret the exact meaning of this, and then decide on the next action. And then this next action is handled by our, sub-dialogue management. And for example, if the user says study mode is the mode comfortable for reading, we can ask a second turn. Okay, give me a value to ask a more specific question on top of the open-ended, can you teach me? And then there's a fourth component, which we call as reasoning. And it is important for this implicit intent. So when the user says, I cannot see anything in here, you need to create this question to the user. You cannot simply say, what can I do for you? For example, if you know that user has, blinds and lights, you need to ask, this disambiguation question. If the user has only blinds, you ask the confirmation question. So there is a bit of a logic related to smart home, and it is configurable. And this reasoning is also framed as a model in the whole architecture.
I think that makes sense, right? You certainly wouldn't want. You certainly wouldn't want it to try and just do things on a whim, right? You'd want to make sure that it's able to communicate with the appropriate devices at the appropriate time based on the types of commands users giving. I think that makes sense.
Yeah.
All right, so let's talk more about this conversational AI that we're describing here, that Rohit so succinctly featured during our launch announcements last week. But I've heard that the ability for customers to teach Alexa was actually inspired by how kids actually learn their first languages. So, can you elaborate on that? What does that exactly mean when we think about how children learn versus how we want Alexa to learn from our customers?
If you look at the current conversational AI systems, not only Alexa, all of them, neither of them actually learn from the interactions, like live interactions, and this is actually the norm in humans. When you tell the kid, oh, this is a nice bike, the kid sees the bike, ground this concept with this image, and then, oh, okay, it is called a bike. and then maybe next week, she's a like a tricycle, and she asks, "Oh, look at the bike," and mom corrects, "No, it's a tricycle, it's not a bike." Or maybe reuses in some context. "Oh, I want to have a bike." Or when you say, "Look at the red bike," the kid simply transforms the color red and then says, "Oh, look at the red car." So everything is about interaction. So most human kids don't learn the language by reading books. They interact with the people around them. And this is actually very, very challenging for the conversational AI systems. We try to build these conversational AI systems by showing them books in a way. So now this is probably exciting in that respect. This is one case where system can learn from the interaction.
Very cool. Yeah, I think when you think about that transference and how children learn, I think that's a great way to explain it. That thing is a red bike. Well, that's how they learn their colors. And I actually used to spend a lot of time thinking about how awful it would be for a parent to introduce their child to the wrong colors, to call colors by the wrong names. Because we as humans, I think we can agree, we all see different variations of color, right? My son has some color blindness for red and green, so he doesn't really see those colors terribly well, or he can't tell them apart. And so we've just all kind of come up with this common language for what these colors are, even though they may not really be the same colors that we're each seeing. But then being able to transfer that and apply it to, oh, that's a red car, or this is a red apple. I think that's it makes perfect sense when we talk about humans, but I can imagine just how complicated that must be for a conversational AI system. So that's a really
I'm also colorblind. In our case, my daughter corrects me. This is not purple. This is blue.
My son asked for
or vice versa.
My son asked me for Skittles the other day, and I gave them to him, but I said you can't eat any until you sort them by color. And he had to separate all. And he did a really good job. I think he had a couple of green ones with the red, but otherwise he did a fantastic job. But it was he knew, it was like, come on, Dad, that's not fair. But it was just a fun activity. All right, so you mentioned something earlier about when we talk about these learning opportunities, that it's wide open. There's so much possibility in what someone could say to Alexa when you say, well, what does reading mode mean? So if a customer's response to, hey, can you teach me that, isn't a valid definition, how does that work? How do we handle those kinds of situations?
Yeah, this is why we decided to go with a full dialogue in the teaching session. Otherwise, you can simply handle it with a single shot, right? But in our experiments with this system, we have realized that a good chunk of cases, this kind of capability is new to people. They don't even know how to answer.
Right.
They have not seen a conversational AI system saying, "Can you teach me?" So we have actually did a bunch of variations of this prompt, like I need a value, can you teach me? What is the value? Or just open-ended, can you teach me? People get most delighted when it is open-ended, like can you teach me? But then this pushes the burden on the AI side. Because it is easier to ask, for brightness, give me a percentage between 0 and 100. Then it is becoming more like directed dialogue. But when you say, can you teach me? Then it is a delight. This is why we have all these guardrail models in the backend dialogue manager. This is why we have the follow-up mode. Sometimes people try unexpected things like I cannot see anything in here. Do you want me to turn on the light? Yes, to 60%. So it is all of a sudden becoming turning on the light plus setting it to 60% brightness, or it is too cold in here. Do you want to turn on the thermostat? Yes, but only by 1 degree. So there are all these, complexities you need to take care.
Yeah.
And you need to ask all these follow-up questions. And then once you engage in a teaching session with the user, you better succeed in doing that unless the user is, uncooperative. So we are trying to make sure that when we engage into this teaching session, we can actually handle that use case.
Got it. Yeah, I think I have one follow-up question to that for the most part, and that is every time that we talk about this, I say I'm too cold, and the assistant comes back and says, "Would you like me to lower the thermostat or raise the thermostat for you?" Is there a reason that we ask and we don't just do?
It is a CX problem, like conversational experience problem. And there are actually different philosophical schools if you talk to these conversational experience people.
Okay.
Some people are in the camp that let's do, and then let people stop us or negate us when we take an action. The other school says let's first get users confirmation, and even you can actually see this maybe like case by case. Different approaches make sense, and there are lots of CX studies happening just on this topic.
Very cool. All right. Well, that's good to know. It's just one of those things that I always wonder, as we decide to take an approach, why we decided to ask a question or why we decided just to do the thing. But that's an excellent answer. Thank you. All right. So you've been a part of the conversational AI community for a while, and you've seen the evolution firsthand. We've talked about all the places you've worked and the things that you've had an impact on. What's the most notable thing about this launch, the learning opportunities that we have here? Besides like the obvious things where it's like, oh, this will make Alexa better, how does this push the industry forward? How does this change how we think about conversation?
Since maybe after like 2015, 2016, deep learning based approaches became prominent in conversational AI. And the systems have improved a lot, not only language, but also, speech processing side. But if you look at the experience, there are still lots of cases where Alexa says, "I am sorry, I don't know how to do that," right? And then what we are trying to do is, can we have like a leap from this to open a orthogonal venue to improve Alexa? Because every day the models are improving. Every day speech recognition is improving, language understanding is improving. But then you need a different mechanism, and then this kind of interactive teaching is one way of doing that. It is not a new idea, as I mentioned before. You can see papers and even PhD theses on this area. But the problem is it is extremely hard for the machine to learn the capability from the user. And people try to narrow it in various ways. And we believe now we have the sweet spot for enabling it. And then this feature will extend, we hope, to more, domains and capabilities of Alexa.
Excellent. I'm looking forward to that future. I think that's going to be good. Okay, so aside from that specific feature that we've talked about quite a bit now, and certainly people got to see a slight demonstration of that during the device launch. What other ways are you working on making Alexa more conversational?
So the other demo Rohit Prasad, VP of AI, showed was actually very exciting. That in that case, Alexa was following the conversation between two humans. and then one of them says, Alexa, join the conversation, and then it becomes like a three-party conversation. And Alexa understands when she is addressed using speech, language, and computer vision features. This is super cool, and this is, I believe, going to enable us to do much more exciting stuff. So Alexa becoming like a member of the household. Um, so at a higher level, we are trying to make Alexa more conversational, more natural, and then with this interactive teaching, more self-learning. And the other dimension is enabling this kind of rich experiences for Alexa users and developers. Last 3 months, we also demonstrated Alexa Conversations, where developers can actually build rich multi-turn dialogue experiences. For example, the scenario there was planning a night out, covering, making a reservation at a restaurant, booking an Uber, and then checking some movies. And these are actually all advancing what is possible today in conversational AI. And I am actually very glad seeing all these science efforts leading Alexa.
Very cool. All right, so I think the idea of join the conversation is actually really pretty cool. There's a number of times where you want that to start, and then you want Alexa to kind of back out of the conversation. I just needed you for a moment. I think that's actually absolutely going to change the way that people think about using their assistants in their homes. Because right now it's a very one-off, right? You turn, you look at everybody in the room, and you're like, all right, hold on a second, I have to talk to Alexa, and like it's a very meaningful, almost I need some silence process to be able to make this thing happen. And then once you get your answer, then everybody can go back to doing what they're doing. But the way it was illustrated, at least in the video that I saw, when they were talking with the Echo Show 10, they were just they would turn and talk to the device when they wanted an answer there. Otherwise, they would talk amongst themselves. And I just think that's a game changer for a number of applications of voice.
Yeah.
So are there any other customer facing, maybe things that people are watching that they've seen? Are there any launches or improvements that you personally are most proud of, things that you've invested your time and energy into?
You mentioned Echo Show 10. I think this was very inspirational because Echo Show 10, following, the person in the room. This is so exciting. I believe the future of conversational AI is, multimodal conversational AI. And then with this kind of devices, there are so many, exciting new capabilities Alexa can offer to customers. And this is also related to the, grounding I mentioned, kids learning, this is a bike, this is a red bike. Now, Alexa will have the eyes, in this demo, Alexa's eyes, were following you. This is a very nice demonstration of computer vision. And when we, mix these kinds of technologies with speech and language processing, there are so many other cool things we can do.
Yeah. Well, I will tell you, I've already checked the box on the Amazon.com website to get an Echo Show 10 inside my house as soon as I possibly can. So I'm really looking forward to that, being able to have it pivot and rotate as I move around and see what's possible from some of this.
Yeah.
So I know that there's a number of interesting blogs that cover a lot of the topics that we covered today, like teachable moments, and as the science advances, I think that the best place to find a lot of this information is on Amazon.science, which if you guys haven't had an opportunity to go there, it's a fantastic website that includes videos like this, but also lots and lots of information about the kinds of research and outcomes that our Amazon Science organization is working on. So if you'd like to know more about those things, you can jump on there. I think you can even subscribe to their blog. So there's lots of other great information that you can find. But Amazon.science, that's the place that you'd want to go. So, Gokhan, I can't thank you enough for joining me today. This has been eye-opening for me, for sure. The fact that there is a person that has been working on all of these different conversational agents for so long, and that I got to spend an hour talking to him is just, it's fantastic. And I really appreciate you taking the time. So, are there any other closing thoughts or anything you want to share with the audience before we wrap things up here?
No. Thanks, Jeff. Thanks for inviting me. It was a pleasure for me.
Certainly. Well, I want to thank everybody for tuning in. Thank you all for your participation and attention. And this video will be posted up on the Amazon.science website very soon. So keep an eye out for that if you want to refer people to it or whatever. But thank you again, Gokhan. Thank you to the audience for being here. And thank you to everyone. We'll be back here again very, very soon. Bye-bye.